So this is episode 18 of Prologue is Amazing. And today I was looking at what functional reactive animation or functional reactive programming is, which came about over 20 years ago, I think, from either Cornell Elliott or Paul Hudak or someone. So it's basically it was kind of, they started off in Haskell, I think, and it's basically about being dependent on time, writing functions that depend on time, and then some extra things added like events on top of that. And this has gone on to inspire things like reactive programming and stuff for user interfaces, but that's a different concept. The original concept was things depending on time. And so having looked all through that, I realized it's like you can kind of do that in Prolog, or another way to say it is it naturally arises in the context of Prolog, right? Because in Prolog, what you have is backward chaining. You have a database, and you do inference. So you have some facts and some queries, and you query for something. In functional reactive programming, the basic idea is to query things based on time, and combine. So like there's components, there's things in the system, there's functions, and they depend on time. So given time and maybe other events, they depend. Now in that one, for example, the one video I saw was about Yampa, where they even have like integration and differentiation built in. So I watched a presentation on it, and it was about functional reactive animation. So you use the Yampa library with the Gloss 2D graphics thing on library on Haskell, and you can easily create animations. And so having understood all that, it's like it seems like Prolog is a very, I mean, I think you can do it in other programming languages too, but it seems like if you naturally thought about it like Prolog or even an SQL database is the right way to think about it. It's like if you have things based on time, then let's say time is like 25 seconds, or 4.5 seconds, then you just write a bunch of queries that depend on that and maybe other events in the system, and it's like a set of views on based on that, and maybe mouse click or mouse cursor position, or previous things that might have happened. And in that framework, you can think of integration as basically summing up the previous values, but it's not. And in Yampa as well, they have integration, but they kind of explain like it's not, because in a continuous space, doing integration is a difficult thing. So it's not numerically, it's not accurate. But if you do it yourself as well, it's like you sum up values, but taking how small of a integral, the steps in the integral matters, right? Like if you take the values of every 0.1 second, it's going to be different from taking values at 0.001 seconds, the sum of the thing. So yeah, but so anyway, coming back to the point, it does seem like the natural way to program is in Prolog is very much like how you would think about things in functional reactive programming. Um, and, right, and so um, and even if you take the other kind of functional reactive programming, then the way everyone else has done it, it's sort of a presentation from the Elm programming language. It's like they think about it in terms of signals and streams and discrete streams. So that's like Prolog actually, because it's like um, you could think it's like for let's say it's a user interface, you could query where each piece of the user interface is from the database and then place the thing there, and you can record information into the database, and like the queries naturally come from the database, like the new information is calculated from the database. And so yeah, so rather than uh, like there's a pull model, right? In the functional reactive programming is about pulling stuff out. That's Prolog, right? Backward chaining, rather than pushing things through the system, right? Because the reason why they wanted functional reactive programming is so it keeps the functional paradigm, like not having mutable state. So if given you always get the same, you keep that functional referential transparency. Given the same input, you always get the same output. And in this particular case, the time is in the input is time, and other things put on there, but basically time, and you will always get the same result. Whereas if you do you, uh, in other ways, things like user interfaces or animations, you're doing a push model, and then you might have objects, and you send messages to objects, and they retain information, and they do things. So it's like a forward system, propagation of values through the system, and then not only that, but you'll have state and mutable state, and is what functional programmers are trying to avoid. Now, in the context of Prolog, if you use the proper Prolog um, philosophy of not mutating state and not asserting to the database, then you maintain that. So whatever the database is, like you could have it as new facts are added to the database in only once. Like, I mean, so you have a state of the database, these facts in it, and then you query over that, and then it's like a game loop, and then you can put new facts in and query over that. So yeah, it's a natural fit. And then I was thinking, that's a great way to do animations in Prolog. It's like you should start to think in terms of the concept of time.